Good afternoon. I hope everybody had a great lunch. Professor Zhu and I went over and had a separate side lunch with some university visitors that were here on campus, but not to come to this. And when they found out that the CERIAS Symposium was going on, they are going to be joining us for some of the sessions later, but they're touring other areas of the conference. But as many of you know, CERIAS operates sort of as a pseudo-consortium that we have strategic partners, and many of you in the audience are connected to our strategic partners and sit on our board. But this was, in our day, this was a good lunch because CACI is on campus just said, we're in. So we're now adding our 23rd partner to our consortium. So they'll be joining our board meeting. So very excited to announce another one. But this whole lunch reminded me that we actually didn't do a formal thank you to any of our partners. So it's up here on the placard, and I do know that they're being recognized in the slides. But I formally want to say thank you to all of our strategic partners who are in the room with posting this, that this is a cybersecurity conference and it's out there on the web. We get phone calls all the time, typically from .com organizations within cybersecurity that said, we'd like to sponsor your conference. And I say, there's only one way to sponsor our conference is become one of our strategic partners, because we're always trying to push value back to them, and we're not all that excited in somebody paying $5,000 to get their name on a plaque here. I'd much rather build partnerships. So thank you again to all of our current partners, and any organization that is not one of our strategic partners, we're happy to discuss what that all entails. So moving along, this will be our first technical talk of the conference. And you'll see, as I mentioned this morning, we are interdisciplinary. So we look for leading research, mature research in various departments, and I'm super excited. I have the opportunity to sit down with Umit in his very first semester here at Purdue, and when they recruit him up here to the Polytechnic, and he started telling me about his research, and the light bulbs just kept going on about the things he could work on. And so he participated in one of the panels a year or 2 years ago? 2 years ago?
3, I guess.
3 years ago? Okay.
Yeah.
But his research at the point and his schedule allowed that I'm super excited to be able to invite him to share his research. These are supposed to be tidbits. He's not going to give you the deep dive, but he's going to give you enough that you're going to want to seek him out later and learn more about that. So with that, Umit Karabiyik from the Polytechnic, it's all yours.
Thank you, Joel. Thanks, everyone, for coming to the talk today. I think there are 2 times that are the worst times giving a presentation, just before the lunch and after the lunch. And I got one of them. So, okay. But I'll try to keep it as like broad as possible. So I'll be happy to talk about these some of the projects that I've been working on with you individually or as a group together. So you're welcome to discuss. So my name is Umit Karabiyik. I'm an assistant professor in the Computer and Information Technology Department at Polytechnic here at Purdue. And I'm also directing my Ubiquitous and Mobile Investigative Techniques and Technologies lab. So in our lab, we do actually seriously work in interdisciplinary work and also multidisciplinary work. And what we dedicate ourselves in this lab, pursuit of digital understanding, it is very important for us so that we can help others, and also safeguarding and advocating the user security and privacy, as well as the advancement of digital and cyber forensics. And in our research in general, what we try to do is we identify, we analyze, we expose the flaws and abuses in technologies. The goal is here really to educate the end users as well as help forensic investigators, particularly in law enforcement. So we work hand in hand with the law enforcement in most of the projects. So as an outline of my research today, what I'm going to be talking about is what is digital forensics and what is it isn't. So it's very important to little bit touch on this topic and some of the challenges that are being addressed or faced by the forensic investigators, and forensic intelligence, how it can be integrated into forensics, and digital forensics procedure, like contemporary digital forensics procedures, as well as the other way around, how the digital forensics can be incorporated into intelligence services, and also some of the applied projects that I've been working on. So what is digital forensics? well, probably it isn't digital forensics. That's what people think. That's where people learn forensics, right? From the CSI movies and all these, episodes. I mean, actually, one of the YouTube video, I wasn't sure if I can actually run the YouTube video, like 16 seconds. It's actually teaching us that we can actually catch the hackers by tracing their IP addresses just by creating a GUI interface using Visual Basic. So that's what's being covered in this video. So, so let's go back. What is digital forensics, right? So digital forensics, the procedure itself was very well defined by the former director of Defense Computer Forensics Laboratory, Ken Zatiko, I guess, last name. So he defined this very well. And if you focus on some of the points, that it's for sure it's an application of computer science, but we can actually call it now, it's computing sciences. Really, it's more than purely computer science anymore. And the goal is really to collect evidence or evidentiary, the data that has evidentiary value. But what is really important in this procedure is to have a search authority following the chain of custody, and also using the validation techniques with mathematics, hash functions, and also using the validated tools, making sure every single procedure and process and findings can be repeated by others by following the same procedures, and at the end, reporting an expert testimony if possible. So this is a traditionally known procedure for digital forensics. And as you can see, it's simply CSI without blood. We don't really deal with blood. But is it really true? I mean, it's not really exactly the case, because now digital forensics, under the forensic science discipline, it is so much integrated with other disciplines as well. And we do actually sometimes have to take into the physical evidence, like blood or DNA or fingerprint, into account, because they might be found in digital devices. And also they might help to unlock digital devices. So they are all now integrated. So thinking this that's why my topic was the holistic view or holistic approach. We have to think about the other forensic sciences all together and think about it as an interdisciplinary area. So what isn't digital forensics is quite a bit confused. It's data recovery and disaster recovery. So, well, can digital forensics be used for these purposes? Of course it can be used, but it's not really exactly it is. But again, there's an intersection here. For some of the agencies, it is not really necessary to follow hardcore digital forensics procedures, right? And these are particularly the agencies dealing with more intelligence gathering and collecting more information about certain threats and mitigating certain threats. And for those agencies, digital forensics sometimes mean really data recovery and disaster recovery. And we actually covered this part also in our one of the projects. So digital forensics procedure is a very well-defined, again, and NIST publication 800-101. So it's a special publication. And it actually very well defines the procedure that needs to be followed in order for any evidence being admissible in the court of law. So the first step is identifying the evidence, acquiring the evidence, and protecting the evidence. So this could be a digital hardware, and then some data inside that hardware as well, located in the hardware. And eventually what we do after we acquire the data, we process it. The process, second step is the processing stage, or it's another words called examination stage. The goal is really reduce the amount of data to the manageable size. It's also called triaging, and it has different names for different investigators. It could be public, private, or even intelligence community. And the next stage is analysis stage, or analyzing the data. The goal is really here to having the best information, or gathering or collecting best information after reducing the amount of data to the smaller amount, and get the useful data out of this. And eventually, the reporting phase shows all the analysis results. So the goal for any of the forensic procedure, it could be forensic intelligence, it could be digital forensics procedures, is really answer the 5W or 5W1H or 6Ws. simply answering the question when, where, why, who, what, and how. But the question is how we can really, answer all of these questions. Well, sometimes it's easy. It's as easy as we use some tools, we, feed the data, or we call it image of the data most of the time, into the system, and it just, simply shows us some of the, doesn't work. Some of the, information in some form, of course, like timestamps in epoch style, epoch time, and, in plain text messages. This is one of the research findings from an application on a mobile device. It's as easy as this. But sometimes we just a little bit dig into the data and look at the logs and some of the information and find some more information in the logs. So this might be easy, sometimes might be challenging, but there is an approach is always being followed, is following the lowest hanging fruit in the forensic procedures. Like usually the tools we use, they show us nicely, categorized evidence is being found on the target device, and then say, oh, if you are interested in the pictures or photos, look at here. If you're interested in emails, look at there. So, but again, the data is not always there. We just have to think from various different aspects, not only being depending on one tool, one approach. We need to think, holistically. And there are some techniques that are being used for this. One of them is pattern of life technique. It can be used actually to understand for the data from various different perspectives and aspects. We can better understand the data and what the data is telling us, rather than what's being shown by the tools. So one example here from this data, actually, when you do the analysis, this is some data sources from an iPhone device. It could be some health-related data, and we can collect the floors, distance, steps, heart rate. But how are they going to be integrated into the forensic investigation? And how are they going to be useful for forensic investigation? It's a really thinking process. The investigator should take into account some other aspects, some other data, and actually not only focusing on what the tool tells them, they need to think about how this data can tell them other stories about some other data that might be found in somewhere else. Like, for instance, one example. If there's a suspect is suspected to plan a bombing or some terrorist attacks, and their phone is being seized. And if the phone is analyzed, and obviously text messages are analyzed, and there is nothing in the text messages. And it's the lowest hanging fruit. It's right there. Text messages and one of these categories. Text messages are there, and then you look at there, it's not there. But there are some certain structures, like write-ahead logs or some other structures, that every single typed and then erased content might be actually found in those contents. So it doesn't necessarily tell whatever they have written and then deleted, doesn't necessarily dictate that this person actually is a criminal or have been performing some criminal activities, but it might tell some information. What was the intention initially? What were they planning? Because all of those drafts in every second, some in different intervals, might be stored somewhere else. So all of these needs to be taken into account instead of just focusing on one data is being provided by the tools. So when we come to the intelligence collection, most of you aware of the intelligence collection most likely. So there are a lot of different ways of collecting intelligence, and that could be OSINT, HUMINT, MASINT, SIGINT, and MINT, MINT, or MINT, or media, IMINT, image intelligence. So different agencies, certainly collect these kind of information. But what we really focus on is the OSINT, the open source intelligence, because we can assume that every single law enforcement agency or every single investigator who definitely don't have access to the rest of the intelligence services or data. So OSINT is basically collecting evidence from the public domain or open domain, open access domain. It could be just some news, websites, and blogs, and for academics, academic journals, academic conferences, proceedings, and the websites of academics for their blogs. And it could be also from the public data, some government reports, or some other agencies' reports. The data can be collected from them and be used during the investigations. So how and why it should be really used? Because when we think about the crimes, crimes are not only, of course, petty crimes, and they are not only dealt with the smaller law enforcement agencies. When the crimes are getting bigger and bigger and bigger, they are getting actually more sophisticated and more complicated. So different approaches than just traditional forensic investigations actually are needed. So forensic intelligence is highly being suggested to be integrated, but it's not, unfortunately, at the same level as its importance dictates. So, of course, the benefits we can get if we incorporate the forensic intelligence into digital forensics, it could be we can disrupt the crimes and prevent them, hopefully. It's usually digital forensics is known to be a, like reactive approach. Things happen, crimes happen, then we collect evidence and find like who did this and when it's happened and why it's happened and how it's happened. Like we try to answer these questions. But we can actually prevent the crimes. We can actually disrupt the crime efforts or criminal efforts. And it's going to definitely help for the time and cost efficiency. It's going to provide time and cost efficiency. One of the projects that we are working with, NASIC, the National Air and Space Intelligence Center, so they are totally focusing on this. We do have time. We have huge data that we don't want to spend that time, that huge amount of data. So how can we make sure that the data collected from the various different intelligence sources can be understood without using traditional digital forensics techniques, because they are not limited to the forensic procedures. So it's actually a huge help for them. Of course, the first part as well. So early identification of suspect is going to be very useful. If we collect information, intelligence from one case, it can be helpful for the other cases that potentially some connections or links can be established between the cases and suspects can be identified earlier. And of course, more effective use of forensic traces that inform policing and also security actions. That Interpol is actually doing this very well. I can say that. They do a lot of good connections with various different intelligence services and do actually stop and prevent significant amount of organized crimes. And of course, general tangible benefits of related intelligence products, such as threat and risk assessment and situation reports. That's also one of the benefits that we are trying to get on another project I'll be talking about. We are working with FEMA, DHS and FEMA on this, just to train some of the higher level administrators on cyber attacks and better understanding of criminal activity as a whole as well. So I'll be talking about 3 projects today. So briefly, I'll be talking about them, that we try to incorporate forensic intelligence approaches and traditional digital forensics approaches, and also some cybersecurity approaches like blue team, white, and red team approaches, and actually purple team as well. So into one interdisciplinary or multidisciplinary project that we can answer or we can address to the challenges that they are dealing with. The first project was, this project was funded by NIJ. This project targets to help criminal justice institutes, particularly correctional institutions. So the goal on this project, basically, the first to develop the AI-based system, AI-supported system, to help the offenders to successfully re-entry to the community. In other words, we try, by using AI techniques and some of the other intelligence techniques, to reduce the reincarceration rates of the offenders when they are released under supervision. And what we are going to do, in order to do that, we are going to deploy a system. We are working with the Tippecanoe County Community Corrections, and we will be working on 125 participants, and they are going to be using our technology, wearables, and smartphone, so that we can collect some data and help them to achieve their goals, because the app's name, actually, we named it Goals, Gaining Occupational and Life Skills. Our goal is to help them to accomplish their goals in life without going back to their previous life and committing crimes again. So, and what we do, we analyze what we are going to do at the end. We are going to analyze the data is going to be collected from these devices, and see the impact of ASMS. So here, what I'm showing on the right panel is one of the forensic techniques that we use. We collect geolocation data constantly from these individuals to make sure this data that represents truly where they are, where the devices are being used, and compare if this data can be validated by some of the other promises that they have given. Because these individuals released under supervision, they have to be at certain locations. And there are many other different ways of deceiving, of course, the systems. But we are trying to make sure that these individuals are where they are supposed to be, and constantly providing this data to their specialists who are working with them to make their life in order and a successful re-entry to the community. And so another approach that we are using is using an AI. This is in progress still, using an AI to identify the surrounding, so where these individuals are, if they are somewhere, by analyzing the ambient noise, if these individuals are with certain group of people, if these individuals are at certain locations that they are not supposed to be, like bars, taverns, and these kind of locations, if they are, of course, in their list of prohibited locations, or where they are not supposed to be. And also, we also identify where they are supposed to be. So all of these cross correlations are being made by collecting the data, to really using the forensic techniques from a watch, smartwatch, and Android smartphone. So other project, this was a collaboration with Lockheed Martin. This project has different aspects, but I would like to focus on the part that we use the intelligence, and how we use the forensic intelligence techniques and actually open source intelligence techniques, as well as some of the cybersecurity best practices. So in this project, the goal was, first of all, highlighting the technical gaps in a region where there's a conflict between two countries, and it's actually a real conflict, and happening in a location, and there is a harsh terrain in the region, and there are some certain attacks between one country is receiving attacks, like drone attacks. So this project specifically focused on the identifying the limitations in the defense systems, particularly long range and short range missile defense systems against the emerging air threats, and particularly focused on the UAVs, and later on we focused on the missile attacks, like long range missile attacks. And the second is to model and simulate a solution to these limitations, and making sure that the defense can be made better for the defending region. And lastly, we propose recommendations for the near and long range, long-term future modifications and enhancements for the currently available missile defense systems in the country. So as you see in the left image, there's a green line, and then the line actually becomes purple. So in those lines, there's an emerging threat. It's a drone attack, and because there's a very harsh terrain, it's a mountain, very steep mountain, and there's a multiple drones are attacking to a certain critical infrastructure. The current missile defense systems do not engage with this, because that purple, that means they are not being recognized, or they're out of range. So our goal was to identify, by using open source intelligence, of course, we were not provided any other information, using the open source intelligence, how we can make this system better and enhance, so that at least one, if possible multiple, defense systems can detect and eventually engage with these incoming drone attacks. And we tested our model and simulation with multiple number of drones. We range, I think the range was from 10 to 30, pack of drones attacking to do certain locations. So we wanted to basically test the limits of the defense systems and how many of those incoming threats can be eliminated in given with the given system capabilities. Another project that we use open source intelligence particularly is also is called Karabiyik. It's Cyber Resilience Adaptive Virtual Reality Experience. This project was funded by FEMA, and this is actually one of its kind. Truly, it might be applied to some other domains, but this is one of its kind for FEMA that FEMA has never provided any training to their stakeholders in VR environment. And this is an ongoing project still. Some of them, actually almost half is done. We are creating a whole course for FEMA so that they can actually host this on their page, and particularly for the mid-level and higher level executives and those who are making decisions during cybersecurity attacks during the natural disasters, and how they can actually react to these. So incident responders, well, for the lower level incident responders, they do have some procedures, they do have best practices. But when it comes to the higher level, the incident command post, it may not be that clear for these individuals to make decisions. So our goal is to train the above mid-level decision makers so that they can actually understand the threats, understand the risks, and understand the challenges so that they can actually react to these problems. In these, we create real-life VR scenarios, and we cover certain things. We cover the prevention and mitigation strategies briefly, but our focus is on the continuation of the recovery and response operations, because most of the cyber attacks we have seen are available in the open domain are simply happening during the disaster. There's an attack. The goal is really take benefit of these disasters so that they can gain some financial or some other political gains from the attackers and criminals' perspectives. And the second is to disrupt the response and recovery operations. Like if there is any incident happen, and then the first responders are responding to the incident, but there is another attack. Let's say attack to their smart grid, their traffic lamp systems, so that they cannot actually, or they cause panic in the city, attackers, so that they cannot reach to the certain locations. So the natural disaster cannot be recovered, and response operations might be halted. So this is also another project. This project was also started with another seed project. I would like to mention and would like to thank West Lafayette and Lafayette Police Department. We create the training scenario with for the police officers that, if you remember the first slide, I was talking about that we don't deal with the physical evidence like CSI without blood. Actually, we do, and after corrected actually make that comment. So the physical evidence actually becomes very important, and this one of these images are showing a real case that the whole case, child porn case, was solved by finding the physical evidence. Of course, that physical evidence was supporting digital evidence eventually, and that physical evidence was a box of a camcorder behind the couch. And the only reason was actually that everything was solved, the puzzle was solved, because the serial number on the box was associated with the video posted online, and the serial number in the metadata of that video. They were a perfect match. And eventually, the suspect confessed. So the physical evidence plays a really important role in digital investigations and vice versa. So therefore, we always suggest to keep in mind that using open source information and thinking out of the box for digital investigations will always help, and help to view the issues and investigations holistically. Just 2 citations over there, and this is my lab's QR code, and my email is there, umit@Purdue, and you're welcome for any questions. Thank you.
Thank you. Very interesting. There are 2 I see, I do a lot of work in the court as an expert.
Yes, intelligence is a huge problem for court. Yes.
So I do a lot of work as an expert witness. I'm a computer scientist, and I do a lot of explaining to the jurors what to make out of all of what we're seeing.
Yep.
There are two enormous problems that we have, and those are selection bias in the data and confirmation bias in the investigator. Are there techniques that you are exploring or recommendations that you are making that can address that? And before you answer, one other bit of background I meant to provide is in many cases, the data will be made available only to the government, which is to say the prosecution. The defense is denied the ability to compel the production of evidence that would be in their favor. Now, the lawyers can argue about why the constitutional problems arise here, but this is a serious problem that is, in fact, affecting us right now, and in my view, is actually undermining the legitimacy of our field.
Yeah, I mean, it's a huge problem in this domain. I know we have been talking to some other experts as well. They are dealing with this problem. What we do for the selection problem is, this is a good question for me because one of the projects I didn't mention, we are working on it, is targeted data extraction. That the selection is actually can be done later on as well by preserving the data and actually integrity of the data. So what we do, we allow the law enforcement to select certain type of data. Actually, that was a 3 years ago talk. Then we actually extend the system for multiple devices, helping the investigators to select certain data types, and then later on, if it is being questioned, the report can provide where the evidence exactly found, and if they want to, challenge this, if they can obtain the data, they can actually work and find exactly where it was. But sometimes, I agree, the data is not being provided to the other parties. I mean, I don't know how that can be solved. Of course, this is a big issue. What was the second question?
Confirmation bias in the investigator. So the way that they play off.
Yeah, they're.
So it's like to give a concrete example. So imagine that you've got a violent crime.
Somebody's charged with committing a violent crime. In one case, you have the government come along with all of the records from AT&T or whatever, and they do all of this estimation. This is the tower you're talking to, yippity-yappity. And also, they will provide some other sort of stuff like some GPS data that they got from whatever. In another case, unrelated, the circumstances may be the same, but we don't have any relevant GPS data from the device, so they've got pictures of whatever, and it's just not at the same date, same time, doesn't matter. But they do not have and will not secure the records from the phone company that would show us what towers they're talking to, but then they will say, well, this guy was over there, and this second case has no way to get to the data that we know the provider has that would be able to establish which tower his phone's talking to.
Yeah, that's a very good question. Actually, I want to point one of my students in the room, Mirza. He's actually working similar to this problem. Exactly, we are having the same challenge. I focus on the mobile forensics investigations more, mobile devices, and we have this problem. Sometimes the data that we get cannot be verified, but with this pattern of life approach, that's what we are trying to actually develop right now. We can get and prove the existence of that data, even though the data, the total justifications are not being provided, by finding some other relevant data. And actually spatial data analysis is going to help us for this, especially for geolocation. And that's what Mirza's work, specifically working on that. That's going to be hopefully helping us to understand what was really going on, and how we can prove the existence of this data with other available data. That's a hope, but we are working on it. I know this is a huge challenge.
We should talk later.
Yep. I appreciate that. Yes. Thank you. Any other questions?
Very interesting work. I like your approach, applying machine learning into the forensic field. Now, one of the questions I have is, when you investigating the digital forensic, the evidence, the privacy is certainly going to get in the way. So, just from the digital forensic community, are there any discussion to say maybe we should also thinking about a privacy preserving evidence, or what might be this, the direction to go for folks in your field?
It's a very good question, and it's a huge concern in the digital forensics field, but there are cases, right? There are certain cases privacy is not even a concern. I mean, if it's it's not about the privacy, it's really if the data that you are getting is relevant to your investigation or not. And there's a case actually here, is Riley v. California. After that case, I think 2015 or 16 case, after that case specifically, Supreme Court ruled that the investigators cannot look at the data that are not directly relevant to their investigations. For instance, so they know the incident happened like, last night, between a certain time frame, 9 p.m. to 12 p.m., right? And then they know that it's a, let's say, hit and run case, and the witness actually brought their phone, and I took the image or video of a car, hit and run, and here's my evidence, but they are afraid of their privacy, right? They don't want to reveal their phone to the police because maybe there is something else. Yeah. I mean, that's a huge problem. And Riley v. California actually prevents any illegal searches and looking at unrelated data on the devices. But for the criminal cases, it might be Riley v. California case still applied to that problem, that the data is not relevant to the investigation, must be excluded from the investigations. And of course, subsequent cases coming out from those unlawful search of the data.
Okay, thank you.
But machine learning wise, yes, we are being criticized on this, the bias and the privacy, all these concerns. But at the end of the day, the law doesn't necessarily favorable on machine learning, that we can't directly use the results of machine learning. It has to be, eventually at the end of the day, the expert must testify for this, right? Expert must understand the results from machine learning and confirm the findings.
Very good, thank you.
Yep.
This is fascinating work that you're doing here. One question, as a former prosecutor, the decision on what to disclose or what matches the relevance and the targeted aspect of the investigation, who is sifting through the data lake to make that determination?
Who's going to make the determination?
As to whether or not the request is related to the specific data. In other words, who's the adjudicator to make that determination?
So the targeted data extraction tool that we are developing is particularly for witnesses and victims. It's not for the cases of, for the suspects or, criminals. So for that case, we give a consent form. The consent form actually appears on the device at the first time when the victim or witness sits down with an investigator, and they actually choose the filters and limitations of their, search and seizure, and then they give consent to the investigator. And then the tool extracts the data accordingly based on the consent received. And the consent is actually very well defined and also signed by the owner of the device.
Interesting. I'll have to think about it.
And yes, and I'll be happy to talk about this because we have also training on this for the law enforcement officers, prosecutors, and judges as well, how to use these technologies.
So have you thought about lashing that up to different jurisdictions who might be looking at the same person, but they don't know it?
We haven't focused on that because probably that could be actually a great, extension of the project. The specific, requirement for this project was really to focus on the witness or victims in a, specific jurisdiction, which is usually the local jurisdictions.
Sure. Thank you very much.
Yeah, thank you.
One follow-up, since we got the former prosecutor question, actually, is have you seen any case where you dealt with where there's something like a special master or I think where did he go? Areas. So there was a case I was working on where we had the concept like a taint team. So we had an unrelated attorney and also a computer scientist sit down and go through this. And the idea was basically, so instead of having the machine just go through and filter things out, is that you would basically have an attorney and a computer scientist that would train that would be involved in that. So that was sort of the legal oversight. Have you dealt with any of those kinds?
No, never dealt with that problem. But I know in Europe case, because of the GDPR, after following the GDPR, it was prohibited to make direct decisions after the machine learning. I don't think we have it here in the US. It is still, I believe, as far as I know, my knowledge, it is actually recommended to sit down with an expert and understand the details. But for the Europe, it's not that case. They totally dismiss the results from the machine learning. It only can be taken as an advice so that they can actually go ahead and find actual evidence and testify for it.
Actual evidence, I'll say.
True evidence in this case. Thank you very much.
Umit, thank you very much. So I'll use this as an example of saying we oftentimes get to hear, well, academia is only dealing in pie in the sky type ideas, and none of it is applicable to actually the real world. I hope this one talk has already dispelled that part of the university's land grant mission is to move the world forward, and I think this is research that obviously shows that it's not pie in the sky, it's not theory, it's actual work that can be put to practice.